वेलकम टू लेक्चर नंबर 4 ऑफ सॉफ्टवेयर डिजाइन कोर्सेज स्टूडेंट्स। आज के लेक्चर में सबसे पहले हम ये देखेंगे जो लास्ट लेक्चर में हम लोगों ने वी हैव प्लेड एक्सपी प्लानिंग गेम विच रेफर्स टू एक्सपी एक्सट्रीम प्रोग्रामिंग सॉफ्टवेयर प्रोसेस मॉडल. आई होप यू हैव लर्नड दैट हाउ दिस थिंग एक्चुअली simulate in a real-time world. In today's lecture, we will be discussing the last software process model of this course, which refers to Rational Unified Process, commonly known as RUP. The reason of choosing this software process model is that it is the state-of-the-art software process model, and it basically follows a demand-driven and very mature methodology, which is basically a UML-based technology. In the course of time in this lecture, we will be discussing all of these aspects in quite detail. To begin with, this process model was initiated or the work began on this software process model in 1995. At that time by the famous gang of three that were commonly known as Rambuch and Jacobson. These three guys were working in a company which was known as Rational Rose. And they kept on working for like 7 to 8 years till 2003. They come up with a very mature idea of Rational Unified Process. In 2003, the Rational Rose company was taken over by or acquired by IBM. And since then, this RUP process model is basically a brand logo which is marketed by IBM. Anyway, to start with, RUP is also an iterative software process. But in addition to the software process, this is also a software product framework. What does that mean? This means that using RUP, we can develop a very mature and very sound software product basis, on the basis of which we can deliver a software to our marketing team. Okay. Now this RUP is basically based on object-oriented methodology, which is a very demand-driven and state-of-the-art technology. UML diagrams are the core of RUP. Use cases and other related diagrams which are used in UML, they basically form the basis of Rational Unified Process. RUP is basically an iterative, incremental, and architecture-centric software process model. This means that the architecture of the software will be evolved in multiple iterations. The software design of the product will never be finalized until the last iteration or until the last deployment. Since RUP is also a product-based software process, so the design will keep on changing in due course of time because there is a difference between a product and a project. Product is basically owned by a company which generates its own requirement on the basis of the research and development which is taken care within the premises of a company. And the design of a product is never finalized in a software industry. Actually, it will keep on changing, it will keep on evolving by the customer feedback which the company will get from the market. And in contrast to the product, a project basis, the requirements are given by the clients. We have to keep in mind that the client will never give us an unlimited time. So we have to finalize our design within the time frame given by the client, and then we have to develop the software and deploy the software within the given constraints. By constraints, I mean the costing, the budget, and the time frame at which the client expects an executable software product. Okay. Now coming back to the RUP is basically works on the basis of the best practices. In the extreme programming approach, we have discussed this concept, but I would like to reiterate again here. Best practices are not hard and fast rules. Best practices are basically the experiences of the software companies which they have learned over a period of time, and they make it out to the IT industry that if a company will follow these best practices, the success ratio is more. Now, by success ratio, I mean that the rate of failure may be reduced, but it is not guaranteed. As compared to rules are strict binding, that if you will not follow a particular rule, a particular software process model will not be validated. Now, RUP is not a very strictly based software process model. It is a highly configurable process. By configuration mean that no single process fits all the problem of the client. For example, if we have several industry-based solution available in the market, but the client says that I don't want a industry-based solution, then you have to think out of the box. You have to go out of the way. That is mean that RUP basically provide the core best practices, but these best practices are not fixed. Mean our technical team should not be limited themselves within these best practices. Another feature of RUP is that each process is highly automated. By highly automated mean that at the one side we have the basic best practices, and on the other side we have a supporting software tool which exactly maps a particular process which is available in RUP. That means there are software tools, there are software capability models which are available to validate the outcome of each process or each phase which is available in RUP. As I have previously mentioned, RUP is basically an representation, or it is generated on the basis of UML. So UML is very effectively representative in this RUP process model. Now I would like to discuss, there are basically 7 best practices which are industry oriented. These are core best practices. Overall there are 9, but the rest of the 3, these are optional. Now I would like to discuss each of the best practices individually one by one, so we can focus on them individually. The first best practice is iterative development. The concept of iterative development is almost the same as we have previously discussed, that iterative development will generate or it will create a better understanding of the user requirements with the passage of time. And in iterative development, we basically address high risk earlier in the life cycle to mitigate them later in the life cycle. Mean those requirements which our technical team feel need more time to mature, we handle them firstly as compared to those requirements which our technical team feel that they are not as much critical as the previously one. And each iteration of the RUP process end with a executable release of a software, which means that we have to produce a running software as per the requirements which were finalized in a particular iteration. So our development team will stay focused on the results rather than other things, because the timelines are there and the technical requirements are there. So our technical team will be focused on producing the running software product. Now here I would like to mention that since this is our first release and this is not the final version of the software, this will be basically a running software which at the end of the release number 1. Now the second best practice is to manage requirements. As I have previously mentioned, that as RUP is following object-oriented approach to develop the software, for requirement management, UML basically provides us with a diagram which is known as use case diagram. Use case diagram is basically generated from use cases which are actually the requirements given by the clients. Now there is a difference between the requirements given by the client and use cases. Use cases basically present a model of the requirement or a model of the system which a user expect from our side. Use cases are basically representation of the systems which actually a client wants from us in a given time frame. Now these use cases basically derives the software design and the software tests which are conducted in the later part of the software development process. Now along with these two functionalities, use cases basically also provides us with a function of a traceability. By traceability I mean there should be a coherent relationship between the use cases which we have gathered as per the requirements and the design artifacts or the design output which are a technical team which we will be developing within the software house to map exactly with a particular use case. I mean that to each use case, we basically give an ID to map that what output we generate against a particular use case. So just to trace out a specific problem later or down in the software methodology. This is very important because there should be an established procedure or standard operating procedures between the different phases. This is what we call the documentation. This feature basically was not discussed in XP as it was not present there. Now, the third best practice was component-based architecture. By this, I mean that it basically follows an policy of divide and conquer. Mean we basically break up our whole problem into the smaller chunks or smaller subsystems, and then we handle the smaller chunks or smaller subsystems in isolation. By in isolation mean that each subsystem basically is a running software function or a running software module, which actually represents a couple of requirements, or in our case use cases, which our technical team or the requirement team generates as an output. Now, this component-based architecture is highly module, and it basically focuses on the concept of reusability. Each component can be tested independently, each component can be used independently, and the market-driven technology is that the companies basically sell these components to earn the revenue. For example, Microsoft says that there is an add-on to the Microsoft 2000 Word 7 or Microsoft Office that if a certain company want to purchase, there will be a functionality of voice recognition also. Now, this voice recognition thing is an independent component which is developed in isolation by Microsoft and is marketed by the company, and this independent component will work in coherent with their existing technology with which a client is using. Now here I would like to stress that I have already talked that we will be purchasing the component of Microsoft. What if I want to purchase a component of Oracle? Now Oracle is a separate brand, Microsoft is a separate brand. What if I want to integrate both of them under one umbrella? Here the idea of Korba will come. I will just discuss this thing very briefly. Korba mean that there are two systems which are not homogeneous. By homogeneous I mean they basically belong to different company. By different company I mean each company has its own set of rules, its own constraints, its own definitions of the software product. If we want to make two different software products or two different components work, we have to define a third-party tool or a third-party standard known as Korba, which will act as an intermediary between Microsoft and Oracle, so that our client can use the functionality of both. If we want to, if for example we have an existing software which is having a database of SQL Server, which is a Microsoft product, and we want to export some data from SQL Server to Oracle RDBMS 11i version or whatsoever, then this cannot be done directly. Here the concept of third party will come. For example, Korba, we will develop a third party tool which will read the data from Microsoft SQL Server, convert it into a way which Oracle can understand, and then save it to the Oracle database. Now these components basically are the representation of a working software model, and these are very costly software components depending upon the functionality and the requirement and the criticalness of the user. Now the example of some components as per the processes that for each domain, here I would like to mention that components are not only developed for executable software products. These are developed for requirements, these are developed for the designing, these are developed for the testing purposes. these are also developed for the configuration purposes. As you can see in the diagram, there are layered approach of the different components, and the different components are interacting with each other in the due course of time. Now, the fourth best practice which RUP follow is the availability of visually modeling a software. By visually modeling a software, I mean that, for example, if we get our requirements and we generate use cases, now we can actually see, or we can develop a use case diagram into the computer software, most probably known as Rational Rose product, which was now owned by IBM. So we can basically see visually how our system will look like. This will provide a very good abstraction of the user requirements without getting into the software implementation detail. And this visual representation of the use case model basically is a blueprint of the software construction, which will increase and enhance the capability of the technical team to develop the software in a very mature way. The next best practice which is inculcated into the RUP process model is the verification of the software quality. UML basically assists us in verifying the software quality by providing us a software quality metric. By a metric, I mean that it will basically provide us with the parameters on the basis of which we can say a certain software is a good software, a certain software is a bad software. Now, don't take these words as literal meaning. By literal, I mean a good software may be a bad one in an eyes of another person. So it is not like a building, for example, a building is a huge one and there are 6 buildings and these are fixed. There is no fixed software quality parameter, and there is no concept of a bad software, because software quality varies from a client to client. So the mechanisms of software verification are built into the UML diagrams, which a user can use to assess a software quality in a relative term on some score-based models or some scoring. The next best practice is the change control management. Now, this is a very important and very critical best practice. What if there is a change in a requirement, or somebody says, or a developer says that they want to change something in the existing software. Now, the change in the existing software code is not simple one. We should be able to track it, we should be able to bug it, and we should be able to monitor it, that where the change occurred, where the bug was there, and what happened to that bug, and what is the current status of that bug, whether it is resolved, it is still pending, or it is under consideration of the technical team. All of these phases are highly documented, because the identification of bug is a very critical thing, but the more critical thing is its resolution in the existing software code, because our developer basically work in a common working environment using a software, and each developer is allocated a workspace. By workspace, I mean a memory in a common pool of working environment, which is isolated of the other working software developers. If a developer A is doing programming in its workspace, other software developer won't be accessing that workspace. So a software developer will be working in isolation to the other existing software or software developers, because to manage a change, the isolation of software developers from other is a very critical thing. And this thing basically lead to what we called in a software industry a production phase, in which we basically generate a build of a software. Now, a build of a software basically compromises of the requirements which were finalized in the requirement phase, the design which was finalized in for an iteration, and the executable software code. The multiple components which we have previously discussed, each component is tested independently, and then multiple components are combined to generate a software build. Now each component should be able to work with each other, or they should be able to work with the existing other software components to generate a build. This build is basically a end product of an iteration which we called as a release. Now the way to show this release to a customer can be multiple. One way is to deploy this release to our own servers and give the access to the client to that software. Another way is that you can upload the software at the client server and the client can see it. Or the third and the most simple way is just go to the client side, deploy the working software model there, and get the feedback from the software regarding the requirements which were finalized by the client. Now, this diagram basically shows you, as I have previously discussed, that there is a very rich support of automated software tools for each process. As you can see in the diagram, for each process or for each best practices in the RUP, they are corresponding software tools. For example, to develop for the iterative development of the software, they are requirement management tool. To generate use case models, there are visual modeling software available like rational rows and stuff like this. So UML basically is highly mapped with the best practices which are available in the RUP for the technical team to follow. After this brief discussion, we will now jump to the processes or the phases which are actually a part of RUP. As you can see on the existing diagram or you can see on the slide, the process of RUP is basically multi-dimensional. On horizontal axis, you can see the time flow, and on the vertical axis, you can see the workflows or the discipline. Now, first we will discuss the horizontal flow. On horizontal timeline or on the horizontal axis, you can see the sliding time, and there are basically 4 construction phases or 4 phases of RUP which are changed over the period of time. Now, there are basically 2 activities running in parallel. On horizontal axis, the time is changing, and on the vertical axis, the disciplines and their granularity is changing. By granularity mean the involvement of a particular discipline against a particular construction phase. For example, in the inception phase, the business requirement or the business modeling effort is more as compared to the elaboration phase, because in the phase 1, for example in the iteration 1, if we are doing the business requirements, this will take more effort, and as compared to the rest of the disciplines like requirements, analysis and design effort, it is less than as compared to the business modeling. But as we creep toward the right on the timeline on the x-axis, for example, if we jump onto the elaboration phase, the effort which is put in by the business modeling workflow or the business modeling discipline, it will keep on reducing, and the time required for the requirements and analysis phase, it will be more. This means that as we jump from one phase to another, the intensity of each discipline which is on the vertical axis, it keeps on changing till we end up with a working software. Now on the bottom you will see there are elaboration 1, elaboration 2, construction 1, construction 2 and so on. These are basically iterations that for each iteration the 4 phases will be repeated, mean inception, elaboration, construction and transition. And for each phase or for each iteration, the vertical disciplines will be there to manage a particular phase. As you can see, for example, in the inception phase, there is no configuration and change management thing, because in inception phase, we are basically generating or we are basically mapping the user requirements to the use case model. So we put in more effort in the business modeling, and this thing will keep on changing. I would like to mention here that the time flow represent a dynamic feature of the RUP, and this vertical axis or the workflow basically it defines the static aspect of RUP. Now, we will be discussing each phase of the RUP in a bit more detail, so you should have a deeper understanding that what each phase does. Now, the first phase of the RUP is inception phase. This phase basically identify the business case, or it will finalize the scope of the project. This means that we have to limit the customer out of multiple requirements, that certain chunks of requirements will be a part of first iteration, and then we develop a working use case model. For example, that use case model will not represent the actual percentage of the complete software. Maybe it will represent a 20 to 30 or a 25 to 30% of the whole system. That means that our iteration is a part of a complete software solution. It is not the software solution. Now, when we will develop the use case diagram, it will provide us with a credibility, or it will provide us with a first documented thing that will be available to our technical team. The milestone of this inception phase is the generation of life cycle objectives. Life cycle objectives mean it will highlight the scope, it will highlight the priority based requirements, it will highlight the initial use case model as a milestone. And keep this thing in mind, each milestone is supplemented by a time frame, and a milestone basically become it is basically an output of a particular phase, and it will become an input for the next coming phase. In our case, the next coming phase is the elaboration phase. The elaboration phase is a phase where basically we jump from low risk operation to high risk and high cost operations. That means if our requirements are not gathered properly, mean the milestone of our inception phase is not generated correctly, then we will be generating a wrong or not a good software design, because the main activity which will take place in the elaboration phase is the detailed analysis of the domain problem, and we will establish a more detailed version of use case model, and then we will start focusing on the architectural aspect of our software. For example, we will be start generating the components of the software, we will start generating the subsystem of the software. But keep this thing in mind, all of these components, subsystems, layers and other diagrams, they are basically derived from the use case model, mean they are derived from the milestone of the phase number 1, which is our inception phase. So this is very critical phase and a very costly phase if the requirement phase is not gathered properly. The output of our elaboration phase is the development of software architecture description. That means we have to identify subsystems, we have to identify the components, we have to identify the communication between the components and their dependency. Mean the component diagram of UML language is basically an output of, we can say in a loose terms, that it basically forms the output of this phase as a software architecture description milestone. Now keep this thing in mind, this phase will take our major effort when we are jumping from elaboration phase to the next phase, which is our construction phase. Basically, a construction phase means the development of the software, and we basically start developing the software as per the requirements identified and as per the design finalized by the elaboration phase. We basically develop the software, we start testing it, and we generate user manual for the user, and then we deploy the software within our own premises to test it internally on a very useful metrics or on a very highly established requirement, highly established criteria. Now this is our activity which will take place within the company. Now the last phase of our process model is the transition phase. Now a transition phase basically mean that we release the software product or we release a particular iteration to the customer, or what we say in the industry, to the limited customers, because the first version of the software product or a software project will give us the feedback, and that feedback will form the basis, or that feedback will form the basis of the next iteration to be planned. Though in short term we called the first iteration as beta version. So for each beta version we conduct beta testing. Beta testing means that the working software model is subject to highly change. This working software will change in the due course of time. Now after beta version release we conduct UAT. UAT mean user acceptance test. User acceptance test mean that, for example, within our software house we have conducted a software testing activity, and that activity results in a good software product, but a user at the client side may refer to an existing software bug or may refer to some problem in the software process or a developed software which our testing team maybe they have ignored it. Because just keep this thing in mind, there is no perfect software test. Each software test is subject to a bug. So we cannot say कि हमने एक सॉफ्टवेयर डेवलप कर लिया है, उसको हमने हाईली 100% टेस्ट कर लिया है और अब ये सॉफ्टवेयर सही है. दिस इज नॉट द राइट वे टू परसीव अ सॉफ्टवेयर. A better way to represent this thing also, that after conducting a reasonably stable a test activity, we can say that our software has achieved a good level of testing, after which we can release this software product to our customer. This phase we basically call as a rollout phase. By rollout phase mean we also give this software to the limited community of the customer, but we also release this product to be given to our marketing and sales teams, so that they can now start marketing this software and they should get the feedback from the client. So the change or the requirements or the feedback which the client will give us, it should be a part of the next release. Keep this thing in mind. I am talking particularly about a software product, because the software product never ends. The development of a software product never ends. It's keep on changing. Like for example, Microsoft Office है, वो कभी खत्म नहीं होगा, उसके अगले वर्जन आते रहेंगे. There will be a beta version, there will be add-ons, there will be a components which Microsoft will be releasing at a particular stage of time. Here I would like to mention that a current research in a software industry shows that those companies which are product-based companies, they have a very good market share, or they have a very good repute in the market as compared to those companies which are project-based. Because a project-based company, they have to continuously look for the business, because if one project will end, they cannot make sure that the next software project will come in a due course of time. The reason of saying is that they have to pay their technical team, they have to pay their requirement gathering team, they have to pay their software testing team, they have to pay their other employees. So a project-based company is highly risk-prone as compared to a software product-based company. A product is an ownership of a company, and a company will keep on changing the software product on the basis of their own R&D. They are not depending upon an outer source of revenue as compared to a project-based company. Anyway, coming back to the transition phase, the milestone outcome or the milestone of this transition phase is known as a product release or a executable running a product. In case of a software product, it is a product release, and in case of a software project, this is basically just a mere release, or we can say version number 1, release number 1, and we roll out it to the customer. Now, after having a discussion on the phases of the RUP, Now I would like to discuss some static structure of RUP process. By static structure of RUP process mean that this phase will describe who is doing what, how and when. Mean who are the stakeholders who are actually running the RUP process model when a software development or a software product development take place. They are basically four elements to the static structure of the software process. Number one is worker. A layman term, worker. This will represent the who aspect of the static structure. The next element is activities. Activities mean it is a set of operation. It is a gathering of a set of operations which will show that how a worker is going to work. Worker is basically, in layman term, is basically a person who will be developing the software, but how to develop a software, what requirement to use, these things will be given by the activity aspect of this static structure. And the third one, the critical one, is the artifact. Artifact is basically a new term here which I have not discussed previously. Artifact basically mean what to do. What to do mean artifact will represent that our developers, they will be developing what aspect of a software product or a software project. And the last aspect is the workflows. This is also a new terminology which we have not discussed previously. Workflow is highly mapped to the when aspect of the dynamic structure of the process. Overall, they are basically four stakeholders: workers, activities, artifact, and workflows. And each activity or each element is mapped to each element of the static process of this structure. Now, on the slide, you can see a diagrammatic representation of the three elements which we have covered so far. Number one is activities, artifacts, and workers. On the left hand side of our diagram, you can see that worker is represented by a designer. A designer is a person who may be designing a software design, who may be designing a website design, who may be working on the database designing aspect of the software. And you can see each worker is mapped to the use case realization. Use case realization mean that each worker will be working on a specific set of use cases which we refer to as a artifact. Now, another set of activity is the use case analysis, and these activities are the static portion of the UML diagrams. Mean, first of all, we have a designer who is performing, who is generating the use case or who is perceiving the use case, and there is another worker who is responsible for the use case analysis, because on the basis of use case analysis, our design will be derived. Mean, worker, which in our case is a designer, he or she is working on the artifact which is a use case realization, and the worker is responsible for the use case analysis, which in our case is the activity. So here you can see a trica of the three elements of the static portion of the process. Like this, in our next diagram, a common term in RUP we uses is that a person will wear multiple hats. This means that a worker is having a multiple roles, because we cannot say that this person is only a designer, this person is only a programmer, this person is only a tester, because software tester is also a software programmer and software designer is also a software analysis. He or she will be doing the analysis portion of the software. What I am trying to mention here is that there is a very thin line between all the roles. So on the slide you can see that we have multiple resources like Paul, Mary, Joe, Sylvia, Stephen, and they are having multiple roles. Like Mary is having a role of a designer. She is also having a role of use case author. She's also having a role of use case designer, and a worker is exactly mapped to the activities which is actually the end product of our software process. So Mary is responsible for object design, detailed use case and use case design, and like Sylvia, she is also responsible for the design review, and she is also responsible for the use case designer. Here I would like to stress that you can see one activity is not done by a single resource. Like use case designer worker is also Mary, Joe and Sylvia. Mean multiple persons are working on a same activity to produce use case design in our case. What I am trying to say is that multiple workers, they work in different phases in a different span of time. Broadly we can say that the requirement gathering people, they will hardly work on the software testing aspect, but loosely we can say a software testing person will also work on the programming aspect, or he or she will be aware of the programming aspect of the software product. So those things which are aligned, they can have a multiple roles, but those things which are not aligned or those things which are not sequentially, they can have a different resource person. Now I would like to discuss the concept of artifact, because this is a new concept which we have not discussed previously. Artifact is basically a piece of information produced, modified or used by a process. This artifact is what we can say is RUP specific term, but now these days this artifact concept is also used by other software process model. The importance of artifact is that the artifacts are the output of the one phase, and they basically become the input of the next sequential phase or the next concurrent phase. Now, for example, an exemplary artifact would be use case model. The next exemplary artifact would be a component diagram. The next artifact would be sequential diagram, and so on. Here you will see that each artifact is a representation of a diagram of UML. As in the beginning I have mentioned that RUP is a object-oriented based software process model, and it is based on UML diagrams. Here you can see that the outcome of each phase is basically a singular map of each diagram. Now, the next concept which I would like to discuss here is another new concept. This is basically a workflow concept. Workflow means that it is basically a collection of sequential activities, that those activities which are to be conducted one after the other to complete a particular phase or to complete a particular activity. Workflows basically combines the functionality of different activities under one umbrella. For example, the most commonly workflows in the Microsoft technologies are the SharePoints. SharePoint mean that in the SharePoint technology, there are many processes which are already developed by Microsoft, and they will just give us the add-on for this. By add-on, I mean they will just expose their APIs to our programmer, and our programmer can use those API for their internal processing. For example, to print a document, if we have to write a program, it may be a very lengthy program. But if Microsoft does this functionality for us and give us some programming API that we can use to print a document, that would drastically reduce the software development time. And that is the main essence of workflows, to reduce the development time in a mature and a professional way, which is highly structured and documented. So workflows basically, they represent a concept of unification of different processes under one umbrella. And as previously I have referred that in UML diagram, as you can see on the slide, there is an example of a workflow. Now there are basically 4 layers, or on the left hand side there are 4 different workers who are working on a particular activity. On the left hand side, you can say there is an architect there, and there are three designers. Architect is working on the sequential aspect of a software architect, and a designer is working on the use cases and object analysis and the review of analysis. Now, the input of the activity which is conducted by the architect becomes the input of the designer activity. Now, if we combine all of these four layers under one umbrella will become a workflow. Practically speaking, in a software development working environment, there is a concept of macro in Microsoft Excel and in other programming languages. Macro mean that if you have to do or if you have to perform multiple activities, you don't perform them individually. The working of each individual activity will be done once over its lifetime, and then after the execution of the activity, the functionality of the activity will be saved under a combined name. For example, A, we have a macro A which perform addition, subtraction, multiplication and division of some values. Now, if next time we want to perform these four operations in a sequence, we just have to call a macro A, and this macro A will automatically perform these four activities in a sequence for us. And now this thing will drastically reduce the time of execution of, or the time of which a programmer need to develop these four operations every time. Mean the concept of a function, the concept of a macro, and a concept of a workflow, they have a direct one-to-one mapping with each other, with one exception. Workflow basically does not always refer to a programming. It also is also referred to the software processes like requirement gathering, designing phase, analysis phase, then the deployment phase, and the configuration management phase, and other processes like this. Mean workflow is a combination of the soft processes and the programming processes of a particular software process. So now in the end, I would like to show you a chart which will show you the phase-wise mapping of a workflow with its related diagram in UML. Now you can see on the slide that for the basic workflow, mean business, or for the business modeling workflow, the representation of the diagram which is available in the UML is business object model. Now business object model it is a bit more abstract version of use case model. Mean in this model we don't go into more details of the technical aspect of requirements. Now for the second workflow, which is our basic requirement, for this workflow we have a use case model, generically says use case diagram. Now this use case model or use case diagram is a more detailed version of business model, because this use case model will become the input of the technical team. Now the third workflow, which is a very critical one, that is A&D, mean analysis and design. Now for against this workflow, we have multiple UML diagrams, like we have activity diagram, we have sequential diagram, we have a class diagrams and the packages. Now you can see the class diagram is the last step before implementing a software. Mean this is basically the last step blueprint of our software design. It will represent the number of classes, it will represent the relationship between the classes, and then we further break up our classes into packages. Here I would like to just mention a point that packages contain multiple classes. So in our software design, what we end up with is basically a couple of packages which will be representing a couple of classes which are converted into the software executable code. And then for the implementation side, we have the actual classes and objects. Now keep this thing in mind, this object has nothing to do with the object in the business object model, because business object model is totally focused on the business modeling, and this object is totally referring to the classes which are being implemented practically in the form of the software code. So the implementation side, the classes are basically our ownership of the software, or it is our actual software code. Now another workflow is the testing thing. Now you can see that for the testing purposes there is no UML diagram available, because UML diagram basically helps us in modeling the blueprint of a software, but it will not help us too much in the software development side. So here basically I have just mentioned that iterative testing, it can be a unit test, it can be a stress test, it can be a branch test, it can be a leaf node test, and other testing techniques like this. Now the last workflow is our deployment workflow, which means that which things are required to deploy a particular software at the client premises, and which thing we need. For this workflow, we basically have a UML diagram, what we called as deployment diagram. So on the right hand side, you can see the diagrams having a mapping with the existing workflow. Now this was all about the rational unified process, which I have to discuss, and in the next class we will start with the software design aspect of this course, and that would be all. Thank you.